Why are quantum repeaters vital for a global quantum internet? Imagine sending a message across the world that can't be intercepted or hacked. That's the promise of a quantum internet. But making this a reality isn't simple. It involves some tricky physics. Quantum communication uses tiny particles called qubits to send information. These qubits are often carried by single photons, which are particles of light. But photons traveling through fiber optic cables face a big problem. They lose energy and get disturbed by the environment, which weakens the signals. This is called attenuation. And like regular signals, you can't just boost or copy quantum signals because of a rule called the no-cloning theorem. It says you can't make perfect copies of unknown quantum states. So, traditional repeaters used in classical communication don't work here. This is where quantum repeaters come into play. They split the long communication line into shorter segments. At each segment, they create a special link called entanglement, which is a kind of quantum connection between two particles. Using a process called entanglement swapping, these links are combined, creating a chain of entangled particles over long distances. Quantum repeaters also use quantum memories to temporarily store qubits. These memories help synchronize the entanglement process across different segments. The nodes perform measurements that do not reveal the actual quantum information, but help extend the entanglement. This process allows quantum information to be teleported across the network without physically traveling the entire distance. Without quantum repeaters, the maximum range for quantum communication is limited to a few hundred kilometers. That's far from enough for a global network. Quantum repeaters are the key to overcoming this limit. They will connect quantum computers, sensors, and communication devices worldwide. In practical terms, they could make communication ultra-secure, because quantum encryption is nearly impossible to hack. They can also link quantum processors to work together on complex problems. Plus, they could improve high-precision sensing and medical imaging. Recent experiments have shown that quantum repeaters can work over tens of kilometers. This progress is promising for building larger, more reliable quantum networks. But fully operational quantum repeaters that support a global internet are still being developed. In short, quantum repeaters are vital because they solve the physical limits of quantum signal transmission. They make long-distance quantum communication possible, paving the way for a secure, connected quantum world.